Okay, on this video we're going to be looking at Uranus and Neptune. Here we can see again that prominent ring feature, and obviously not as prominent as the one on Saturn, but all of these gas giants do have rings, which is kind of interesting, and it's something that a lot of people don't know about. Everybody knows that Saturn has rings, but most people don't know that Jupiter and Uranus and Neptune do as well. So that's something that you know that most people don't. So Uranus was discovered in 1781 by Sir William Herschel. We actually talked about Sir William Herschel before. You might remember he's the one that did the experiment where he broke the sunlight into the different colors with a prism, and he put thermometers at the different colors to measure the intensity of all the different colors. Essentially one of the very first spectroscopy experiments ever done. But when you're looking at Uranus from the Earth, it's so far away, even with telescopes, you can't see very much detail at all. This is an image showing, however, that you can see that it does have moons, and you can see 3 of its larger moons there. This is an image that was taken by the Voyager 2 probe some years ago, and we can see some more detail. The coloration is really pretty and interesting, but in a lot of ways, it shares similar features to the other gas giants, Saturn and Jupiter. Now, Neptune is the other gas giant at the outer edge of the solar system, and it was discovered in the mid-1800s after an analysis of Uranus's orbit indicated its presence. Basically, we looked at how Uranus was moving around the sun, and we found that its motion was not perfectly elliptical the way we would expect it from Kepler's laws. There were deviations, and it was determined that those deviations would only be understood if there was another planet gravitationally pulling on it. And so they were able to calculate what the nature of those forces would have to be and where that planet would have to be, and they trained their telescopes there, and voila, there's Neptune, a whole nother planet, which was basically discovered because we understood how gravity worked, which was pretty cool. We can see an image here of Neptune. It looks very similar. It's kind of a darker shade. It almost looks like water on the surface, but it's not water. It's just gas. It's just a gas giant. And here we can see a size comparison. So Jupiter is, of course, by far the largest. In this picture, Saturn actually looks larger because of the rings, but if you consider just the round part here, you can see that Jupiter is quite a bit larger. For scale, here is Uranus and Neptune, which are very similar in size, and here's the Earth, which is relatively tiny in comparison. Now, here is something that is really interesting. It shows the mass and the radius and the density of these two planets. Uranus is about 14.5 times the mass of the Earth. We can see that Neptune is about 17 times the mass of the Earth. They both have a radius that's about 4 times as big as the Earth, so they're very close in size. And their densities, remember the density of water is 1,000 kilograms per meter cubed. This is 1,300, so it's a little bit more dense than water, but not as dense as the Earth or something that would be rocky, which would have a density 4 or 5 times that much. Now, this is interesting to contrast with Saturn, because Saturn actually has a density that's less than water, which is rather startling. If you were to take the planet Saturn and put it on a giant lake, a lake the size of the solar system, it would float because Saturn is actually less dense than water. But these other gas giants, Jupiter, Uranus, and Neptune, they're all more dense than water. So when we speak of them as being gas giants, we have to remember that there are tremendous pressures at play here that affect how they behave. Now, this is one of the interesting things about Uranus, and it's that its axis of rotation is tilted over to the side. And so if this were the Earth, remember the Earth's axis of rotation would be something like that, and the Earth would be spinning about its axis, and that's what gives rise to the seasons. But on Uranus, the axis is in a different direction. We can see that the axis actually, instead of being sort of perpendicular to the plane of the sun, it actually lines up with it. Not exactly, but pretty close. And so those different tilts of the axis is something that makes Uranus very interesting indeed. And that also means that its seasonal variations are going to be much more extreme. So, for example, when Uranus is on this side of the orbit, you can see that what you might call the northern pole here is lined up directly with the sun, and so that would get the brunt of the solar radiation. But in the opposite season, it would be on the opposite side, and so it would be completely extreme, the variations between the summer and the winter, if you wanted to call them that. So Uranus and Neptune are very, very cold. They're very, very far away from the sun. And because of that, the ammonia in the atmosphere freezes. The methane is sort of what provides the dominant chemistry, and that gives it those pretty shades of blue that they are. But actually, they're made up of the same stuff as Uranus and Neptune. They're just very different colors because the chemistry is different because of those temperature variations. Again, because it's so far away from the sun, it's just colder there. Here we see an image of Uranus, which is showing clouds that exist in the lower level. And also you can see the ring system is very prominent in this uppermost picture, which is kind of cool to see. So when you're looking at these, both of these planets, Uranus and Neptune, have band structure, but Neptune's is much more visible. And interestingly, Neptune once had a dark spot that was similar to the storms on Jupiter, although it has since vanished. But that does tell us that these planets, like the other gas giants, they do experience weather, storms, and things of that nature. Now, another thing that's very different about Jupiter and Saturn compared to Uranus and Neptune is the magnetic fields. If you look at the magnetic field of Jupiter, it looks like the magnetic field that you would get from a bar magnet in the center. And the same with Saturn. Now, with Saturn, it's tilted more, but it's that same idea that if you had a giant bar magnet in the center, it would create the same kind of magnetic field. It's the same with the Earth as well. But when you look at Uranus and Neptune, the bar that you would replace with to make the same magnetic field is not centered, but it's offset. And so that means that the magnetic field is very different compared to the rotation angle, and that leads to a very different magnetic field than the other planets. Here we can see the interior features of Uranus and Neptune compared to Jupiter and Saturn. And what you can see here is, in particular, here on the left, that's showing Uranus, and on the right, that's showing Neptune. Here are obviously Saturn and Jupiter. And this figure to the right, which you can see is all four planets, there's sort of pieces of the cutaway, so you can see what Jupiter's interior, Saturn's interior, Uranus's and Neptune's interior are all on the same picture. And that just shows kind of what their structure is in terms of having the rocky core, the metallic hydrogen, the sort of slush in the middle. That is what the interior structure of these planets looks like. Here we see the moon systems of Uranus and Neptune. They, again, are compared and contrasted with the Earth's moon. So you can see all these moons are smaller than the Earth's moon, but some of them are still quite sizable. Now, it's worth noting that compared to the size of Uranus and Neptune, these moons are very tiny. Whereas the Earth, compared to the size of the Earth's moon, or I should say that backwards, the Earth's moon compared to the size of the Earth is relatively very large. But so here you have, for example, these moons here, Ariel and Titania and Oberon. These are all pretty big moons. And if this moon was orbiting the Earth, we would say that was a pretty big moon. But orbiting around Uranus and Neptune, these moons are much smaller compared to their host planet. In a lot of ways, these moons are very similar to the medium-sized moons that orbit Saturn, although they reflect much less light, so that means they're harder to see. One of the more interesting moons, this is the moon of Uranus, is Miranda, which has these very interesting surface features, and the geology behind their formation is not really well understood. So that's something of a mystery yet to be solved. So a bit more about Neptune now. Neptune has 13 moons. Only two of them can be seen from Earth, Triton and Nereid. Triton is in a retrograde orbit, and Nereid has a very eccentric orbit. Um, Triton's surface has very few craters, indicating an active surface. We would expect if the surface weren't active, there would be a lot of craters because it's been hit by rocks and things from thousands and thousands and millions of years even. But because we don't see that many craters, that means there must be some sort of geological activity on the surface covering up or eroding those things away. Another interesting feature of Triton is the fact that nitrogen geysers have been observed, and that is something that contributes to the surface features. And there also appear to be ice volcanoes, and I think ice volcanoes would be a good name for a ska band, but in any case, there are volcanoes that erupt ice, which is kind of an interesting thing to see. And lastly, I want to note that just like we saw with Saturn, that the ring systems around other planets also have these shepherd moons. And so here are these two shepherd moons, which are guiding these rings and kind of keeping them stable. And so, anyway, that is a brief synopsis of things that we know about Uranus and Neptune. And I hope you found some of that interesting, but that will be the end of this topic.